Hey guys, good morning or good afternoon to some of y'all. Okay, time for your new math lesson. Okay, so you all took the test um, last Friday, and so now we're moving on. Chapter 10. That's right, we're moving on. We're a little behind. So I'm going to be picking from here on out, I'm going to be picking and choosing the things that we're going to be doing. We may not complete whole chapters and stuff like that, kind of like what we've been doing, but a little more so. Just because as of right now, it is looking like we're going to be doing this longer than expected. I don't know to how long. You should be hearing something soon, but yeah, I think we're going to be doing this for a while. So just in case, because I really don't know what the future is going to hold as far as your education, we want to hit all the important things first and foremost. That's why we're moving right on to 10. And I don't know just all 10, but you'll find out. Okay, so here we go. Y'all should have gotten an email about how I want y'all to start turning in your homework. It should be easier for you. We kind of talked about that on in the text messages too yesterday. Figure it out. Help step by step. Ask each other for help if needed and everything. Try to do that because it'll be more organized. I can grade like all of one class together instead of all four classes here and there and everywhere. It's a total disaster. So this should be easier for you as well because you'll get an instant grade. You'll see all the comments. Da 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 da. It'll be readable too, unlike the way it's been. Okay, so let's move on. I know you're tired of hearing me talk blah 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 blah. Okay, 10.1. We're doing factoring. Oops, sorry. Okay, factoring. Get my blanket around here. Common monomials. Okay, so you just got through doing monomials, trinomials, etc. Binomials. Remember, monomials was one term, okay? One term. Binomials was two terms, trinomials were three, and then you had your other polynomials. That was when there was more than that, okay? Factoring. The word factoring should ring a bell. That would be like the greatest common factor stuff. Okay, so that's what we're doing right now. The GCF, greatest common factor, of a polynomial is the product. Now, do you remember what product means? Multiplication. I'm not going to put an X there because, well, I'll put a little X right here. Multiplication. Answer to multiplication problem. Of all factors shared. Now, this is important. This word right here, because kids really have trouble with this. But it's all the factors shared by every term of the polynomial. Okay. And you know, as well as I do, a lot of us have even talked. The word notes sometimes don't make sense until after I start doing examples, and then you look back and go, oh, that's what that means. That's what that means. So bear with me. All right, relatively prime. Okay, that is when two numbers or terms, you know, like numbers and the letters together, have a greatest common factor of just one. For example, 3 and 2. Greatest common factor is going to be 1. Okay, so they would be considered relatively prime, basically. Okay, that's what they're talking about right there. There is no other number that can go into 3 and 2 evenly. All right, so steps to factoring common monomials. Step 1, find the GCF, or the greatest common factor, of all terms. By the way, as far as relatively prime, I'll talk a little bit more about that later, okay? We'll come back to it. Step 2, divide the GCF, greatest common factor, out of each term. Sort of like reverse distributive property. Okay, so first you're going to find the greatest common factor of all terms. Second, divide the greatest common factor out of each term. Okay, step 3, write the factorization as greatest common factor times the sum of quotients. I know. Blah, 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 blah is what you're hearing. I get it. Just bear with me. I will show you. Step 4, you're going to check answer by multiplying the two factors. Now, who are we kidding? I know my students. Not one of you is going to check, and you know it. I could sit here all night long, and yes, I'm doing this Sunday night. I could sit here all night long doing all the check and everything. Y'all won't do it. All right, here we go. We're going to just jump right into examples because you guys know that you learn better by examples. So, go ahead and open up your books to page 406. All right, pause the video if you did not have your book ready to go, and come back when you do. All right, examples on page 406. Look at number 1. It says find the greatest common factor. If the greatest common factor is 1, write relatively prime. 45 and 75. This is kind of like a review. Y'all have done this before. So we're looking for the greatest common factor. I'm going to even write that up there. Greatest common factor. Guys, you know what we're doing? Factor trees. And some of you are like, oh yeah, factor trees. Now, keep in mind, it's about to get kind of hairy, but it's okay. You got this. All right, so think of two numbers that when multiplied give you 45. Some of you, I know, are saying 9 times 5. So 9 times 5. You circle the ones that are prime. 5 is prime. 9 is not. So two numbers that when multiplied give me 9. 3 times 3. 3 is prime. 3 is prime, so we circle it. Down here, remember, 3, we write them out. Cross them out. If you parents or if you're watching this too, I tell them to cross this out for obvious reasons. They're going to get confused and they're going to put one more than they should down here, or they'll forget which ones that they've already written down here. So I tell them to cross it out as they write it so that it keeps them from getting messed up or making mistakes. See? 3, cross out, times 3, cross out, and then we're going to do this 5, cross out. Okay, now let's do 75. Two numbers when multiplied give me 75. 5 times 15. 5 is prime. Two numbers when multiplied give me 15. 5 times 3. Alright, so I have 75. Oh, and that's right. Remember, we write things least to greatest. So here's a 3. I'm going to cross it out, write it down. 5, cross it out, times 5. Cross out. So I've made sure that I've written down all my bubble little numbers, my prime factors, in the correct format. Now, if you remember with greatest common factor, we circle our pairs. I have 3 times 5. You only have to write one of them down for parents that are watching. 3 times 5 is 15. So the greatest common factor of 1 is 15. Now, again, y'all have done this before. Y'all have taken tests and everything else. So this is just a review. I'm not going to do a whole lot of examples here. This is just refresh your memory. All right, 5. All right, this one is with letters, and I wanted to make sure I did one with letters. X squared times y cubed and x cubed times y squared. Okay, you don't have to do the factor trees when you do letters. Remember, this is a lot nicer. All you have to do, I'm going to bring down this term, is write it out. X times x, because there's 2 x's, times, and there's 3 y's. Y times y times y. There. 2 x's, 3 y's. See, this is easier than up here because you don't have to do the factor trees. It's like you don't even have to use your brain very much. Now I'm going to do this term. X cubed times y squared. Okay, guys, how many x's do I have here? 3. X times x times x. How many y's do I have? 2. Y times y. Alrighty, just like we did before, circle your pairs. And you only write down, see, there's a pair, there's a pair, there's a pair, and there's a pair. Don't have to worry about that. We're doing greatest common factors. Remember, least common multiples, we'd have to deal with that. Don't have to with this. So we only write one of each. Don't write down 2, just 1 for each pair. Now, what is x times x? Think about it. X squared. What is y times y? Y squared. There's your answer. Okay? That's it. That's it for that. Now then, let's get to the good stuff. I'm going to go ahead and start with a new piece of paper. Here we go. Number 15. Yeah, I'm not going to review that first part anymore. Y'all already had that, and I just gave you a quick review. Watch it 100 times. I don't care, but we got to move on. All right, so the next section. Factor. If the polynomial will not factor, write prime. And that means that there's nothing they have in common, okay? Then it's relatively prime. I typically do not like to give y'all, no. Be careful. If you can't find, if it has nothing, if you can't find anything that has in common, then it's prime. But let's go ahead and start. I'm going to quit talking. All right. 7x squared minus 49xy plus 28y squared. Okay. All right, so what you're doing with this is you're looking at each number and each letter to see if they all have something in common. You're looking at each term. There's 3 terms here. 1, and you're looking at just that. Here's another one. and then here's another term. Okay? Now let's look at the numbers. 7, negative 49, but it doesn't really matter. But 7, 49, and 28. What number, what's the biggest number that can go into 7, 49, and 28? If there isn't one, then we move on to the letters. Okay? So think about it. What number can go into 7, 49, and 28? Excuse me, if you said 7, you're correct. 7 can go into 7, 49, and 28. It's the largest number that can go in there. Now let's look at the x's. There's 2 x's here, 1 x here, and there's no x here. So, do these 3 terms have x in common? No, because this one's missing an x. So it does not have an x in common. So let's look at this y. There's 1 y here and 2 y's here, but there's not one here. So do they all 3 have y in common? No, they don't, because this one's missing a y. So that's what this is all about. You're having to see what all 3 terms have in common. Not just 1 or 2, but all 3. If this right here has no letters in common, so we're going to just stop there and put a parenthesis. 7 divided by 7 is 1. We don't have any x, so I'm just writing x squared. 49 divided by 7 is 7. We don't have any letters here, so x, y. 28 divided by 7 is 4. We don't have any letters here, so I'm just bringing down my y squared. There's your answer. That's it. That's it. That's what you're doing today. That's it. So go back, rewind, look at this problem again so it makes sense. Don't start texting me if you don't understand 15 because we're moving on to 17. So you may rewind and look at it again. All right, 17 is 6a squared plus 48a minus 24. Okay, what number does 6, 48, and 24 have in common? Think about it. Think about it. Yes, they have 2 in common. 2 can go into 6, 48, and 24. So yes, it can. But it's not the largest number that can go into all 3. So keep in mind, it's not just looking for a number that can go in all 3. They're looking for the largest number. 6 would be the largest number that can go into 6, 48, and 24. So I'm going to take out 6. Keep in mind right here, find the greatest common factor of all terms, 6. So far, we haven't looked at the letters. Divide the greatest common factor out of each term. That's what you're doing now. You're doing step 2. I'm sorry. We're doing step 1 by looking for the greatest common factor for all terms, and then we're going to divide the greatest common factor out of each. Okay, so now we look at the letters. A, 2 A's here, 1 A, and no A. So do all 3 have an A in common? No. So we're done. 6 divided by 6 is, or 6A squared divided by 6 is 1A squared. 48 divided by 6, 8. A divided by nothing is A. 24 divided by 6 is 4. And we're done. See? Now, if you want to check to see if you're correct, go back and do distributive property. If you multiply this by this term, you should get 6a squared. 6 times 8a gives you 48a. 6 times negative 4 gives you negative 24. See, that's how you check. Okay, By the way, because some of you are going to ask, usually it's Owen, and I appreciate that. See this 1a squared, and Viviana, you do too. See that 1a squared? It is okay to keep that 1 there. Even IXL doesn't care. You can also write it like this. See, without the 1, because we know that the 1 is understood. So either way, I know, Owen, I know you're very comfortable keeping the 1 there. So, and your answers in the past and everything. So by all means, keep that 1 there. Don't panic or anything. Some of you see that it can be done, you know, either way and may want to change it up. That is your choice. Oh dear, what is that? Oh no. Okay, there, we're back. Okay, number 19. We're doing a lot of examples. Oh no. Y'all still see this? Hold on just a second. Oh my gosh. Where's the recording button? Are we still recording? Hold on. Okay. Something's wrong. Okay. I'm gonna have to probably pause this. Nah, we're just gonna keep going. Okay. It says we're recording. Alright. 6a squared b plus 3ab squared. Okay. So what we're going to do is look for a number and letters that all of them have in common. So first let's look at the numbers. What number does 6 and 3 have in common? That's right, 3. 3 can go into 6 and 3 can go into 3. Now we're going to look at the A's. We have 2 A's here and 1 A here. So they both have an A in common. But how many? This is 1, this is 2. So only 1A can go in here. 2 A's can go in here, but remember we're looking at the greatest common factor, the largest number that can, or letter that can go into both. And so we're just going to take 1A out because that's the largest that can go into that. We can't take 2 A's out of that because there's only 1. So just 1A can come out. Same with this. We have 1B and 2 B's. So the biggest thing that we can take out of there is 1B. Can't take 2 B's out of that because there's only 1. So then I do my parentheses. Okay, 6 divided by 3 is 2. A squared divided by A. Remember, if the bases are the same and we're dividing, we subtract the exponents. So 2 minus 1 is just 1. So A squared divided by A is A, and B divided by B is nothing. Because remember, that would be B1 minus 1, which is B to the 0. Remember that? So B to the 0 equals just plain old 1. We don't need to put a 1 there. So B divided by B basically cancels out. 3 divided by 3 is 1. A divided by A, same as over here, they cancel out. A divided by A is 1, but we don't have to write 1, 1. B squared divided by B is just B. And there's your answer. Or you can leave off that 1 and just write 3AB times 2A plus B. Okay? All right. 21. 91a cubed b squared plus 13a squared b. All right, what number does 91 and 13 have in common? 13. There's A3, there's 3 A's here and 2 A's here. The largest that can come out of this are 2 A's. See? You can't get more than 2 out of that, and there's 3 here. So the largest that can go into both is 2 A's. Then I have 1 B here and 2 B's here. So the largest that I can take out of there is 1. 91 divided by 13 is 7. A cubed divided by A squared, remember that's you're subtracting. That gives you A1. You can say that if you want, you don't have to. B squared divided by B is B. That would be B2 minus 1. Remember, there's an imaginary 1 there. Plus 13 divided by 13 is 1. A squared and A squared, they cancel out. A squared divided by A squared, they're gone. And B divided by B is nothing. So see, Owen, some of you that like to write the 1, it comes in handy here because you had to have that there. If you wrote this times 7AB and then stopped there and did not do plus 1, it would be wrong. So go ahead and write the 1s in there. It's okay. It's not a wrong answer. Okay. 23. 14x squared y minus 15z. All right. Is there a number that can go into 14 and 15? No, there's not. These both terms do not share an x, y, or z. So if there's no greatest common factor, it is prime. Okay? All right. 25. 12x cubed minus 16xy squared. All right, so what's the largest number that you can take out of 12 and 16? 4. Now this one has 3 x's, this has 1 x, so the largest you can take out there is 1 x. This has 2 y's, but this does not, so we can't take any y's out. So we're done. 12 divided by 4 is 3. X cubed divided by x. X cubed. Remember, there's a 1. If there's nothing there, we pretend it's a 1. We're dividing, and bases are the same, so we subtract. That would be x squared. Minus 16 divided by 4, 4. And there's no y here, so then we just bring down the y squared. There you go. I totally slipped over. X divided by x is nothing. Remember, that's that x1 minus 1. That gives you x0. And anything to 0, remember, is just 1. If you were to put a 1 here, that'd be 41, so don't do that. Alrighty. Let's do 2 more. Alright, 27. 56x squared plus 42xy minus 28x. Okay, guys, what number can go into 56, 42, and 28? If you do not remember, this is when it gets weird. You're going to need to do the factor trees. 8 times 7 gives you 56. This is prime. 4 times 2 gives you 8. 2 is prime. 2 times 2. Prime, prime. So I'm going to write 56. And we go least to greatest. 2 times 2 times 2 times 7. All right, 42. 6 times 7 gives you 42. 7 is prime. And 2 times 3 gives you 6. All right, so I'm going to write 42. 2 times 3 times 7. 28. You can do 14 times 2. Oops. Sorry. And 7 times 2. And these are all prime. So then I have 28 over here. 2 times 2 times 7. All right, so what do we have in common for all three? I have a 2 and I have a 7. Notice there's not another 2 in the middle here. So that's it. Only circle what all three have in common. So I have 2 times 7, which is 14. So 14 is the greatest common factor for up here. So now I can go back up here and take 14 out. There's 2 x's here, 1 x, and 1 x. So what can I take out? I can take 1 x. There's no y here and a y and no y here, so I can't take a y out. 56 divided by 14, 4. X squared divided by x is x. 42 divided by 14, 3. X divided by x, again, remember, we're subtracting, so they cancel out. But there's no y, so I can just write down the y. 28 divided by 14 is 2, and x divided by x cancels out, so there's your answer. That should be a 1. Okay, I think y'all are good to go. You can review over all of this. Maybe I should do one more. Because I've been doing all binomials, so let me do one more trinomial. Look at number 29. 7a to the 5th power minus 84a cubed plus 21a. Okay, what number do all three have in common? This one's a little bit easier than the last one. They have 7. This has 5 a's, 3 a's, and 1 a. So the largest, greatest amount of a's that you can take out of each term is going to be 1. So, oh my word. So you take 1 a out. Say hello to my cat. This is Wingo. He's decided to join. No. Okay. All right. Go. All right. So we took 1a out. So 7 divided by 7 is 1. A5 divided by a, remember that's like 1. So you're subtracting because the bases are the same and we're dividing. So that would be a to the 4th power. 84 divided by 7 is 12. A to the 3rd power divided by a to the 1 power. Again, we subtract. A3 minus a1, so that's a squared. Plus 21 divided by 7 is 3, and this is a1 minus a1. It gives you a0. They cancel out. There's your answer. Okay? All right, guys. I am going to assign some IXL. You are going to have a quiz Monday, April 6th. Okay? You're doing today page 406, numbers 7, 8, 9. Okay, 12 problems, 8 to 30 even. And count again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's it. Some are going to be prime. I'll give you a hint. 1, 2, 3. 3 problems are prime. Okay, just 3. So if you find 4, 5, or 6, no, that ain't gonna work. That's due Tuesday. Okay, guys? I am assigning IXL on this so you can practice, and you'll be getting that notification. All right, take care. Miss y'all. Now I gotta figure out how to stop this.